They're bigger than last year's. We don't have a lot of, or we have a lot of stuff to cover, so I won't take too much time with this short introduction. Maybe quickly the schedule, so I'll talk not too long, 15 minutes max. Then we will go through a session of COMPAS usage at ETH, and then a panel discussion focusing on the relationship between COMPAS and AI, and whether this threatens our mere existence, kind of. Then the rest of the sessions focusing on all sorts of different topics. So last year we focused a lot on the core library, and then we had a few sessions about extensions. This year it's the other way around. So I will not go into technical details about anything. The only thing I wanted to maybe quickly remind you of is what kind of the original goal or mission of COMPAS was, right? We know that nowadays, especially, there are a lot of tools, languages, softwares, and etc. available to all of us to develop solutions for the building industry. That's of course great, but making all of these things talk together, connect them, and etc. Maybe this now gets a little bit easier with the help of LLMs. But it's also for seasoned developers rather a complicated task, and so the main mission of COMPAS is actually to make computation in AEC simple, so that we can use all of the tools at our disposal to develop proper solutions for our industry. I wanted to add maybe one additional slide, but then Google decided otherwise, to touch on three other aspects that I think are also important and that relate a little bit to, I think, what will be discussed also in the panel. Which is the not really inventing the wheel over and over again, which I think in the age of LLMs is actually rather a relevant topic. We can, of course, let an LLM go crazy and reinvent the wheel every single time for every single solution. And that's maybe, again, where libraries like COMPAS can play a key role. And then, of course, the do not repeat yourself aspect. And then the collaborative parts, so to allow people across our industry and across multiple disciplinaries to really seamlessly work together. So those are things that maybe also should not be forgotten when we evaluate how to position ourselves with respect to all of these emerging technologies. That's all I'm gonna say about this. Here, maybe again, the way we try to make computation in AEC simple is by organizing everything around a centralized framework, so that you have more a unified API to access all of these tools, rather than having to learn all of the intricacies of all of the different languages and all of the different tools. So there is the centralized framework, and then a collection of extensions and packages that focus on specific tasks and specific processes in this entire ecosystem. So, as I said, this year we will not focus too much on the core infrastructure, but mostly on the extension packages. The only thing that I will do is give you an update about some of the topics we said we would tackle during the course of this year, that we announced last year on the DevDay. One of these things is the migration to Python 3. So as you know, because of the compatibility with Rhino, which now of course changed, but in the past, which ran on IronPython, and not just IronPython, but IronPython flavor 2.6. Or 2.8, sorry. We had to maintain compatibility with that version of Python to make sure that all of our tools worked across the entire ecosystem and not just outside of Rhino. With the release of Rhino 8, this changed, right? So now Rhino runs CPython, and we'll even switch to more recent versions of CPython in the new releases. So this allows us to actually migrate the entire ecosystem to Python 3. As you can imagine, that this is a little bit of work, especially to do that without breaking everything else. For those of you who know, I'm going to show only a little bit of code, but so just to remind you what that means, actually, this migration to from 2 to 3. For those of you who know the code of the core library well, you will recognize stuff like this basically being everywhere. It is from future import, so that we could, even when supporting still Python 2, could use some of the features of Python 3. In many other files, there were a few if statements of try excepts to be able to switch between different versions of libraries. But this, in some cases, evolved into complete import mayhem, as you can see here, which is actually the import statement in the most fundamental class of the entire ecosystem of the data class. So all sorts of tries and accepts and catches and etc. and working with NumPy or not NumPy, or detecting whether we were in IronPython or not, or in .NET or not, and so on and so on. And I can happily report that now, by being able to switch to Python 3, all of this now simplifies to that. So you get a lot more clean, clear import statements. You see also that we can now use NumPy everywhere as a direct import. We don't have to shield this from Rhino anymore, so that will be a big change moving forward. Another thing that we can do now, because of the switch to Python 3, is not only use all of the libraries that come with it, but we can start to add type annotations. So in the past, the best we could do was hiding these type annotations in comments. Now we can use the entire infrastructure for this. Although this doesn't make your code run better or faster or any of these things, it does give you a much better developer experience. It allows you to catch a lot more errors in advance, and it gives you a lot better code intelligence in most of your editors. So I am personally rather excited about this. I'm not sure that everybody shares this excitement. Then just to give you an overview of where we are with this. So in the packages of the core framework, so there is currently a huge pull request which is still in draft for Python 3 and type hints on the core COMPAS packages. And then you'll see that those packages that already existed as extensions or were written as a bind or wrapper around C++ or were so heavily based on NumPy that they could actually not be made compatible in a reasonable way with Rhino anyway in the past, that those were already Python 3 compatible from the start. And then for the type hints, actually with the help of coding agents, which I'll touch on a little bit afterwards, we have converted already quite a few packages to be fully type annotated, and there again, the core packages, they have this mammoth PR that nobody will actually review because it's absolutely impossible, but just needs to be completed before we can merge this in. So this is on main. So as you know, there is like an LTS for. Okay, I'll move a bit faster. Then the second thing that we did, this was actually something rather recent, was migrate to MakeDocs. I think all of you have experienced a humongous headache that is Sphinx. Struggled with it to write nice documentation and so on and so on. And then recently, tools like MakeDocs became actually a lot more powerful and convenient to use. And there you have a bit more like a, for those who know web frameworks, a bit like a Vue style, NPM-based kind of developer experience. And then this allows you to make documentations a lot more flexibly and just conveniently. So this is a bit the signature style of these kind of docs. So we have already converted quite a few. What is actually really nice, just to point it out, on the left is a typical Sphinx-based documentation. So you see that in the parameters, you have all sorts of clutter from annotations that you need to include for Sphinx to recognize what a parameter is, to refer to these classes and so on. And on the right is like the very clean, much more quiet kind of MakeDocs version. So it will infer from the type annotations, all of the links to the code will automatically create these interlinks between other documentation pages and so on. So it provides a lot easier way to write. And actually, this is again something where an LLM is extremely useful to make the conversion between the two. So here also this is ongoing. I would like to say that this MakeDocs conversion is also already part of this PR, but it's not. And then there, yeah, the smaller packages, they have already been converted because, of course, this was a bit faster, and then some of them have not. All right, COMPAS and AI, really quickly. So, as I said, we're trying to figure out where to position ourselves with respect to the emergence of all of these new tools. This will also be part of the discussion with the panel. One thing where I already personally found it extremely helpful is to, for example, make these transitions from old code bases to new code bases, where you can actually provide it very clean, clear instructions that are entirely geared towards COMPAS specific things. And so I wanted to maybe point out a few small things, like for example, you can very easily tell it to write modern Python 3 code, but maintain compatibility with Python 3.9. You don't have to say that it's because of Rhino, but and so that it sticks to certain rules to maintain that compatibility, and otherwise, wherever possible, already migrates to something that is actually newer. So you can very easily mix these kind of otherwise rather complicated instructions. And also things like remove Sphinx markup clutter if it's still present. I mean, you could write a regex for this yourself to somehow figure out how to catch all of these cases, or you can just write something like this and then have it basically convert your entire code base. So what, as you may or may not know, we have organized a little workshop, an improv workshop. It's like the first of its kind. It's like a walk-in workshop. So you just walk in and participate, which will be after the presentations. And so there, Ricardo, I don't see him anywhere. I think he's maybe still preparing stuff. We'll show you, or us, or we will do together a bit of an exploration of how to use these agents, not just to do these kind of dev-oriented tasks, but also so we will start with something very simple, just describe the agent, or describe to the agent that it actually needs to prefer COMPAS code when it solves a certain problem, just to see how this actually shapes your code already, and then go to much more elaborate instructions to actually very precisely curate what it is and is not allowed to do, and then add a few skills to this so that you get a particular end result. And so he will guide us through an example where remember this typical tube mesh in the COMPAS library, where we will planarize this and make all the panels available for fabrication. By basically describing to the LLM what it is. And then visualize this with the viewer and etc. So we will give it a bunch of skills so that when you ask it to visualize something, that it uses the viewer in a certain way. When you ask it to work with geometries, that it does this in a certain way, and so on and so on. Yeah, I think that's exactly 15 minutes. Maybe really quickly, since we are more and more supporting or trying to support the community with being proud about what they make with COMPAS, that's also what today is really about. Gonzalo and team made a bunch of badges that you can now proudly attach to your repository to say that what you did is actually made with COMPAS. Yeah, thanks a lot. And maybe also a big shout out to Gonzalo and team for not only getting us on track, but keeping also the preparations completely on the rails, so that we would actually be able to have this.